made, we put it in the ATR imaging. We put the film, and because we wanted to know how cellulose and ionic liquid in there, you can see 2-3 colors that shows how much it's distributed. That is like a qualitative analysis. Visually, it can give the pictures. The down one is the typical, whether you have done here or not. This is how it looks. The first one is alvin. The second one is, like I said, I didn't raise the question. I said I made the band-aid. That material is water soluble. Okay? But I said I used as a band-aid. So what does it mean? I shouldn't touch any water. I shouldn't go near the water for 3 days. So no one has raised the question. So how it is useful? I made a film. I made a band-aid from seaweed polysaccharide. It's completely water soluble. That's why it's degradable. But still I used as a band-aid. How? Any guess? No guess? I don't know whether you heard the terminology cross-linking. So these polysaccharides are water soluble. It has a lot of COOH because it's a polysaccharide. It's like a star. A lot of COOH and OH groups. It has affinity with water. Like I said, it's a hydrophilic in nature. So it's always try to dissolve. So what we have to do, we need to restrict the motion. We should be controlling the COOH and OH groups. Doesn't make any hydrogen bond. So we have to restrict by cross-linking. Generally they use glutaronic, it's hazardous, but here we use calcium chloride. Calcium chloride is not hazardous. This second pictures, you can see the first one is alvin, second one is the alvin is cross-linked with calcium chloride. So these OH groups are restricted, so I can use the band-aid for a few days, even in presence of water. It's not soluble or degradable. So the last one is XRD, I don't know whether you used. If you want to know or identify my material is crystalline or pore, amorphous in nature, we can use X-ray technology, XRD, X-ray diffraction. Who invented this XRD?
Bragg's law.
L lambda is equal to 2d sin theta. Leave alone the Bragg's law, but the guy who invented the X-ray is the Röntgen. So there is a machine now. We are not going to do it. We have to keep the sample down. We have to record the image. If your material is crystalline, it will give a peak, sharp peak. You will understand. Okay, even if it is a carbon, one form of carbon is crystalline in nature, but another may be amorphous. So this is what we can understand from values. The first one is cross-link, the native alvin. After cross-linking, little bit of crystalline is gone down, it can be amorphous. But other than that, normally alvin is not crystalline, amorphous in nature. Next one, Kumran. Again the film, you see, I did the AFM and this is a smoke. But when you see the 3D, you can see that. These last two pictures, this is how I have made it. My film surface looks like that. So, next comment. I think, do you have any idea about these pictures? I think biotech people, you know these pictures better than me. No. So, like I said, any band-aid, there is material. It can control the antimicrobial property. Also, what should has be done? The cell growth. Then only your wound will be covered, right? So, how to test that? We made the film, we load the cell line, okay? We have to see how many days the cells are growing or dying or so that they identify the color pictures, the confocal images. You see the blue dots. And when you see that, the green one, so the cells are alive. That means whatever you load on the film or the band-aid, it stays for certain days. So that say you can safely use that material. This is what generally people do and confirm. Some people they go for when you want to do detailed work, you have to take this material to the industry or product to the market, you have to do the ethical committee. You have to, in Tanjore, probably you have to go to the Tanjore Medical College. There are a lot of doctors. They check your starting material. They test with several people. They will say it's okay to go. This is how the picture looks. These last two are scanning electron microscopy. This I did the mapping. With the mapping I did, then we understand the first two are confocal images. Next. That's it. Now these are the technique trial and error I use. Different technique we use. Whatever the technique we are end up in getting the major product. The last one I think 14% of cellulose we are getting. So I think we retain the process for further application. From this green color algae, spin on your ocean, we get this cellulose. And this cellulose we can do any kind of material. Next, Kumran. This is the post. Thank you. Yes, your question, Kumran.
Yeah, I have the micro